Welcome back again. In this video, we're going to try to find the set of points that satisfies z times z bar minus z bar equals 0. We're going to plot the set. Here, we know that z is a complex number. So the z is in C. We can do this one in any way we like. I think a quick way is that we can use the fact that we can write z as a plus ib with a b reals and I squared is minus 1. We don't forget this one. Okay. So here we can see that given that if we write a z in this manner, z bar is going to be a minus ib. Okay, and we can proceed and solve. So this is one way. Another way that we can do is that we can proceed directly. We can remember that the modulus of any complex number, so z is the square root of real part squared plus the imaginary part squared. And we know that z can be written as the z times z bar. Okay, so given that, now we have the modulus squared is just z times z bar. And we can use that here. Okay, we can use that here and we can simplify this expression. Okay, note that in this case we have z times z bar minus z bar is, so here we have z squared, the modulus squared. This is z minus z bar. Okay, we can write z, this is minus z plus z bar. So we can write z plus z bar as a plus ib plus a minus ib, because z bar is a minus ib, and we get 2a, or in general we write it in this manner, 2 real c. Okay, so in this case we see that given this condition here and this way of writing the z times z bar and z minus z bar is minus 2 real z. Okay, so the modulus of z squared is a squared plus b squared from here. Okay, we can do that. We can see that this is just a squared plus b squared minus the real of z is a. So we want this set to be this equation to be 0. Okay, now we have this equation here, a squared minus 2a plus b squared is 0. Okay, we can complete the square here. We can add and subtract 1, and we see that this is a minus 1 squared plus b squared is 1 for all a and b real. Okay, so the a and b are real in R. So what's this equation here? Okay, so remember this is the equation of a circle. Okay, the circle centered at 1, 0 and having radius 1. Okay, therefore we can plot this set. We can plot it. So it's centered at 1, 0 and having radius 1. So this is 1. So this is my set. Okay, so it's these points here. Okay, so this is a circle centered at 0, 1 and having radius 1. So this is my set. There is another way that we can do this one here. Okay, we can write these numbers. We can find z exactly. So here we have this point here. It's moved 1 unit from the origin. So therefore z is just 1 plus ei theta with theta in R. So this is the set of points. Okay, to see that try to plot this one here, okay, by setting EI theta as using the Eulerian notation. EI theta is cosine theta plus I sine theta. Okay, so once we do that, we clearly gonna see that we have the same thing. We have this circle here centered at 1, 0, and having radius 1. Okay, so this is one way of doing of finding the solution. Okay, there is another way that we can use here, which is based on writing the modulus without writing it in this algebraic form. Okay, that's another way, but this is quicker, and we use this algebraic form because here the algebra is easier. Okay, the algebra is easy, and we can see that we can quickly find the set that we need.